What if everything you see around you, the very fabric of space and time, is just an illusion? In this explainer, we're going to dive into the pretty wild idea that spacetime itself might actually emerge from a network of conscious agents. We'll even show you two completely different recipes for building it from scratch and how we can check our work.
We usually think of space and time as the stage, right? It's the absolute bedrock where the play of reality unfolds. But what if that's totally wrong? What if the stage itself isn't fundamental at all?
And that leads us to this radical alternative. The idea that spacetime isn't the starting point, but the end result of something way, way deeper. Something built not from physical stuff, not from atoms or strings, but from pure information and interaction.
Okay, so if you're going to cook up space-time from scratch, where do you even begin? Well, you need a recipe, right? And like any good recipe, it all starts with a clear list of ingredients.
All right, let's break it down. Here's the game plan. We begin with a network of these things called conscious agents. Then we summarize all their interactions in a mathematical object called a Markov matrix. From that matrix, we build a geometric structure. And if we do it all just right, the properties of space-time they just pop into existence.
So our number one ingredient is this Markov matrix, which we'll just call P. Think of P as a cheat sheet for our network. It's just a table of probabilities that tells us how likely one agent is to interact with another. And here's the crucial part. This matrix has zero information about space or time baked into it. None. It's our raw, pre-physical starting point.
Okay, so we've got our ingredient, P. And believe it or not, we have two completely independent recipes to turn it into spacetime. The first one is a lot like weaving a tapestry. We lay out a simple grid, and then we define some rules for how paths can move across it. This whole approach is built on a really powerful mathematical tool called the LGV theorem. All it does is help us count the number of paths on a grid that don't cross each other. And I'm going to say it again because it is so important. We are strictly outside of spacetime here. We are not sneaking in any hidden assumptions about physics. This is all just pure combinatorics.
So the process itself kind of breaks down into a few key steps. First, we build a basic mathematical grid that has a special property. Then we use our agent matrix P to pull out a set of numbers. We use those numbers to kind of stretch and scale our grid, creating a final matrix we'll call X. And from X, we can directly calculate the core geometric numbers we need.
And get this isn't just a bunch of theory on a blackboard. This is built and tested with actual code. This is a real command you'd run to check your work. You're basically asking the computer, hey, are all those geometric numbers we just made actually positive? Which is a key requirement for this to work.
And here it is, the punchline for our first recipe. By starting with a simple grid and scaling it with the data from our agent network, we can prove that the geometric numbers that pop out are all non-negative. And we did it all without ever having to assume spacetime existed in the first place. That is a huge deal.
All right, now for our second recipe. If the first method was like weaving, this next one is more like building with blocks. It uses a totally different technique from particle physics. But what's so cool is that they both start from the exact same ingredient, our agent matrix P, and they still manage to arrive at the same amazing destination.
So yeah, recipe number 2 is called the bridge method. And you can really think of it as constructing a piece of space-time geometry by snapping together these fundamental building blocks, one by one.
In this approach, our agent matrix P is basically the instruction manual. It tells us which building blocks, or bridges, to use and exactly how to connect them. By just following these instructions, we build up this complex geometric object that ends up representing a little cell in spacetime.
And just like our first recipe, this is something we can actually build and test. You can run a command just like this one, which takes the agent data and just runs the construction, outputting the final geometric cell.
So the big question, does it work? The script runs a check, and when we see this beautiful little output, plucker non-neg pass true, that's the green light. It confirms that the object we just built has all the right properties. It's a valid piece of the puzzle. We now have a second independent success.
Okay, so let's pause. We have two recipes that produce a bunch of positive numbers. That's great. But how do we know this math actually describes the physics of spacetime? How do we connect these abstract numbers to our reality? It's time for the taste test. The first key is these numbers themselves, the plucker coordinates. I want you to think of them as the geometric DNA of our system. They're the most basic, fundamental building blocks that our recipes produce. the raw genetic material of our little universe.
But, DNA on its own doesn't do much. It needs a way to be expressed. That's where cross ratios come in. By arranging our Plücker coordinates into these very specific combinations, we get numbers that behave exactly like things we can measure in the real world. Things like the shape of light cones, causal order, and even effects like gravitational redshift.
And this right here, this is the moment of truth. This is where it all comes together. On the left, we have our world of math, built from our geometric DNA. On the right, we have the operational world, what physicists can actually go out and measure. And the goal is simple: do the results match? When the numbers from our model agree with the numbers from reality, well, that's our confirmation. That means we've created a structure that behaves exactly like space-time has emerged.
So let's zoom out and look at the whole cookbook we've just followed. What does it all mean when you put it all together? Here's the entire pipeline, from start to finish. We begin with a non-physical network of agents. We use it to build a mathematical object, we extract its fundamental numbers, combine them into physically meaningful ratios, and then we check them against the rules of physics. And if they pass, we have successfully generated emergent spacetime. So what's the big takeaway here? Spacetime, maybe the most fundamental thing in our reality, might not be fundamental at all. It could just be an emergent property of a deeper, purely informational network. And this isn't just some philosophical idea. We actually have a mathematical framework for building it and testing it against the real world.
And that brings us to a final, really profound question. If something as fundamental as the fabric of space and time can be an emergent property of a deeper network, what other bedrock features of our universe might also be projections from something else entirely? What else are we just taking for granted?